This is Chapter 4, the Scientific Notation and the Matrix Prefixes. This chapter has three important sessions. Session 4.1 is about scientific notation. 4.2 is about engineering notation. And 4.3 introduce the prefixes. Let's begin session 4.1, the scientific notation. The scientific notation is a way to write very large and very small numbers. It was designed to write very big number or very small numbers. Here are the three criteria, the rules for writing the numbers in scientific notation. The rule number 1, the numbers expressed in scientific notation can be either positive or negative number. Rule number 2, the absolute value of that number, so here absolute value must be greater than or equal to 1. That means it can be 1 or greater than 1, and it needs to be less than 10. It cannot equals to 10. It can be less than 10. For example, 1.5, that is a valid number. 1.8 is valid. 3.4 is good. 10.1 is not a valid number, since 10.1 is greater than 10 already. For the rule number 3, when a number is expressed in scientific notation, it needs to multiply a power of 10. How about let's take a look at some examples. Such as here, we have a number 3,500. We want to express these numbers in scientific notation. The equivalent scientific notation format is 3.5 times 10 to the power 3. As you can see, the number is a positive number. That means the rule number 1. And then 3.5, right? 3.5 is between 1 and less than 10. Is greater than or equal to 1 and less than 10. Multiply power of 10. So it is 10 to the power of 3. This number is expressed in scientific notation format. Here we have 5 more examples. Let's check each of the numbers to see what numbers are in scientific notation and what numbers are not. The first number, 1.35 times 10 to the power 11. It's a positive number. It meets rule number 1. And then for rule number 2, the absolute value of this number need to be between 1 and 10, right? Greater than or equal to 1, but less than 10. 1.35 is between 1 and 10, so it meets rule number 2. For rule number 3, the power of 10, right, is 10 to the power 11, so it meets rule number 3. This number is expressed in scientific notation format. The second number is negative 4.21 times 10 to the power 5. It's a negative number. The absolute value of this negative 4.21 is 4.21, and the 4.21 is greater than or equal to 1 and less than 10. So far it meets rules 1 and 2. Let's check the power of 10 part. It is multiply 10 to the power 5. So that is correct. This is also a number expressed in scientific notation. How about number 3? It is 10.3 multiplies 10 to the power negative 7. 10.3 is greater than 10. Since it's outside the range, it's greater than 10. This number is not expressed in scientific notation. If you want to convert this number to equivalent scientific notation format, first, we can move the decimal point to the left 1 unit. After moving to the left 1 unit, it is 1.03. The 1.03 is greater than or equal to 1 and less than 10 is in the range. Since we move the decimal point to the left, the number part is reduced by 10. To keep the original value the same, we need to do the opposite for the exponent. We need to add a 1 to the exponent. So at the end, it's 1.03 times 10 to the power negative 7 plus a 1. The result is 1.03 times 10 to the power negative 6. Later, we have a few more examples like this about moving the number's decimal point and changing the exponent. Let's look at the first number, negative 5.41 times 10 to the power negative 33. The absolute value of negative 5.41, it is 5.41. This number is in the range. And then the power of 10 part is 10 to the power negative 33. Therefore, this number is expressed in scientific notation. For the last number, it's 1.602 times 10 to the power negative 19. The number part is in the range, and then the power of 10 part is valid. So this number is also expressed in scientific notation. Now let's have another example. We want to write 10.3 times 10 to the power negative 7 in scientific notation. First, let's write down this number, 10.3 times 10 to the power negative 7. Since its 10.3 is outside the range, we need to shrink this number by moving the decimal point to the left one space. So if we shrink the number part is reduced by 10, right? Divided by 10. Moving the decimal point to the left 1 unit means divided by 10. To keep the original value same, we need to do the opposite for the exponent by adding a 1 to the exponent. So at the end, the number is 1.03 times 10 to the power negative 6. Let's have another example here. Write 0.5 times 10 to the power 11 in scientific notation. As you can see, this number is not in scientific notation because 0.5 is less than 1. To make the number part valid, we need to move the decimal point to the right 1 unit, which means multiply it by 10. If we multiply the number part by 10, we need to do the opposite operation for the exponent. We need to subtract the current exponent by 1. So at the end, it's 5.0 times 10 to the power 11 subtract 1. The answer is 5.0 times 10 to the power 10. Here is another example. We write the 0.05 times 10 to the power 11 in scientific notation. 0.05 obviously is less than 1, is not valid. We need to move the decimal point to the right 2 places, so it becomes 5, and the 5 is in the range between 1 and the 10. Since we move the decimal point to the right 2 times, we do the opposite for the exponent. We need to subtract the current exponent by 2. So at the end, the answer is 5.0 times 10 to the power 9. This is another example. Write the number 0.05 times 10 to the power 11 in scientific notation. First, we copy down the number. If we move the decimal point to the right 3 times, that becomes 5. And then we do the opposite for the exponent. The exponent 11 need to subtract the 3. So at the end, the answer is 5.0 times 10 to the power 8. Let's have a practical example. We know the proton's mass is this number, 0.167 grams. As you can see, there are lots of zeros. If you want to give these numbers to peers or other engineers, other researchers, there's a higher chance either we or the engineer, the peers, will make mistakes since there are lots of zeros. At the time we transfer this number, the number may lose a zero or add an extra zeros. So this is the reason we prefer to express the number in scientific notation. We know if the number is 1.67, this number will be expressed in scientific notation. At least rule number 2 met. So we put the point over here between 1 and 6. From there, move the decimal point to the left 24 places, so the point reached to the current decimal point's location. Therefore, the equivalent scientific notation for this number is 1.67 times 10 to the power negative 24 gram. The reason is negative because we moved the decimal point to the left. Here has another practical example. 1 ampere, 1 amp, equal to this large number. So we want to convert this number to equivalent scientific notation. Obviously, this number is not in scientific notation yet. For its correct scientific notation, the decimal point need to be after 6, right? It should be 6.25. So first we put a dot over here, and then we count how many times do we need to move this decimal point towards right, so it becomes the original number. It is 18 places. Therefore, this number's equivalent scientific notation is 6.25 times 10 to the power 18. The reason it is positive 18 because we moved the decimal point to right.